Welcome back to the fifth lecture on data communication network. We discuss about data communication system, and switches as well as the internet. Let's get into the performance metric of a network. How does the how can we measure the performance of the network? Normally, performance metric based on four major elements: delay, loss, throughput, and jitter. But for time being, because jitter is for only multimedia applications, so that I have restricted our discussion with only three metrics: delay, loss, packet loss, and throughput. Okay, so the most important metric here is a delay. That means in the first class itself, I said that when you remember the first class, the timeliness is something important. Okay, that means the data should reach the destination in the timely manner. Okay, so that is an important metric for network. Okay, so when we talk about circuit switching type network, uh, here take it out an example here. Two nodes, two hosts. This is host A. Let it be this is host 1 and host 2. Okay, connected with the router A and followed by the destination router B. Okay, so whenever the packet is transmitted, then it passes through this router. As you know already, this is a packet switching type network, so it receives the packet and store the packet and then forward the packet. Okay, so store and forward type network, like a packet switching kind of thing. So that is a concept related to internet. Okay, so here if you take this network like this, structure like this, the packet reached the destination only after some period of time. Okay, that time is known as delay. That is time taken by the packet to reach the destination. Okay, so that depends upon several factors. Okay, so what is the first important factor? Whenever the packet reaches this node, this particular router will store the packet. Okay, and it will put it in the queue. It will check the best outgoing link. Here only one link is connected, so it will push the data onto the link. The time required to do all those things are known as nodal processing delay. Okay, so another thing is that normally the buffer maintains a queue. Okay, queue known as first in, first out data section. If the queue is empty, then once a packet entered into the queue, automatically will be ejected out of the link. Okay, if the queue is already filled with some packets, okay, then it should follow the queue. The packet which are preceded in the which are already in the queue to be forwarded, and then the new packet will be forwarded. So that delay is known as queuing delay. Okay, so the queuing delay and nodal processing delay normally negligible. So we'll talk more about this queuing delay and nodal processing delay in the deeper sense in the later class. Okay, but the most common delay is a transmission delay and the propagation delay. Transmission delay and propagation delay, these two not negligible. Okay, so what about the transmission delay? The transmission delay is that this is channel. The time taken by this router to inject the packet onto the channel is known as transmission delay. Okay, transmission delay is the time taken by the router or the host to transmit the data. Okay, transmission delay is a time taken by the router to transmit the data or inject the data onto the link. Okay, transmit the packet onto the link. Okay, so this is based on two factors. That means the packet to be injected onto this link. Okay, the capacity of the link matters. Okay, let us assume the capacity of the link is R. Okay, so R, as well as the packet to be injected onto the link, the size of the packet is also matters. Okay, larger packet requires larger time, less small packet takes less small time. Okay, so the length of the packet divided by the channel bandwidth is a formula for computing the transmission delay. Okay, so the transmission time of the packet is based on the length of the data by the capacity of the channel. Okay, so another property here is a propagation delay. Okay, so propagation delay is nothing but the time propagation delay time taken by the packet to travel in the link. Okay, so this is actually a wired link, or it may be wireless link, whatever it may be. So here the time taken by the router to inject the packet onto the link is L by R second. Okay, but here the packet should travel from one end of the link to another end of the link. It should travel and reach this destination. So the travel time is known as a propagation delay. Okay, so the propagation delay is based on again two metrics. One is if the distance between if the length of the wire is large, definitely the travel time will be high. Okay, so the first one is known as distance or the length of the wire, distance between the nodes. Okay, and divided by the channel characteristics. Okay, so we have different channel, fiber channel or coaxial cable or twisted pair or vacuum air. Okay, so the velocity of the channel plays an important role. If the velocity of the channel is high, then the propagation delay will be low. Okay, because it will transmit the data with a higher rate, much more higher rate. Okay, so the propagation delay is based on distance by velocity. Distance between the link divided by the velocity of the channel. The transmission delay is based on length of the packet by the bandwidth of the channel. The propagation delay is based on the distance between the node by the velocity of the channel. Okay, if you take twisted pair, the velocity will be very small. If you take coaxial cable, the velocity is based on the coaxial characteristics. Okay, but most common channels are fiber channel. Fiber channel, if you take fiber optic channel, the fiber optic channel works on the principles of light. Okay, so that the velocity of the fiber optic channel is based on the velocity of the speed of the light. Okay, so 2.0 into 10 power 8 meter per second. Actually, the velocity of light is 2.5 into 10 power 8 meter per second. So that velocity achieved. But what about wireless channel? Okay, for example, here assume I have the access point. Okay, and the laptops. Okay, so when we transmit the data to the access point, okay, let us assume this is inside the coverage area, and here the channel is a vacuum or air wireless channel, because wireless channel is dominating the entire world. Okay, so in this wireless channel, the data passes through the wire, through the air. Okay, so here also the velocity of the travel or velocity in which the packet travels in this channel is also based on light. Okay, that means 2.5, but instead of taking 2.5, we have to take it out because there is a possibility of interference and all those things. We have to take it out the velocity as 2.048 meter per second. Okay, and one more important point before getting into the program, if you take satellite communication, because wireless is dominating the entire world. Okay, if you take satellite communication, the distance between the earth station to the satellite, because satellites are in a geostationary orbit. Okay, so the distance will be constant because satellite will be kept inside the geostationary orbit. Okay, so what is the difference between the earth to the geostationary orbit? 35,000 kilometer. Okay, so for example, if you take I have an antenna here, another antenna. Okay, when it transmits the data, it will get into the geostationary orbit as satellites. Okay, and then it will transmit it back to the destination antenna. Okay, so here the travel time or traveling distance is something different. Okay, the packet travel from this end to this end and then this. Okay, so now the propagation delay is based on the distance. The distance, you know already, this is in the geostationary orbit. Antenna is located in the earth. Okay, The distance between the antenna and the geostationary orbit is 6,000 kilometer. So here 36,000 kilometer. Again 36,000 kilometer travel to reach the destination antenna. Okay. So propagation delay playing an important role. If you take wireless communication, in specific satellite communication, the propagation delay will be very high because the distance is very high. Okay, even though the velocity remains same because it passes through air, the velocity remains same 2.0 to 10.8 meter per second, but the propagation delay is very high for satellite communication. If you take short range wireless communication, then the propagation delay is much small. Okay, so the propagation delay it increases with the increasing distance. Okay, if the distance between the nodes are high, then the propagation delay will be high. The transmission delay heavily depends upon the capacity of the channel. If the capacity of the channel is high, the transmission delay will be less. Okay, but propagation delay heavily depends upon the distance between the node. Okay, if the distance between the node is less, then the propagation delay will be less. Okay, so here the transmission delay consideration we have to think about the channel capacity, that is denominator, for the propagation delay point of view, because there is no velocity remains same. For fiber channel, the velocity is 2.5 into 10 power 8 meter per second. For wireless satellite communication, the velocity remains same 2.5 into 10 power 8, 2.0 into 10 power 8 meter per second. Okay, only one factor is that the distance. If the distance is high, propagation delay will be high. If the distance is low, the propagation delay will be low. So here also, if the if R is high, then the delay will be low. Transmission delay will be low. Okay, transmission delay will be low. Okay, if you take propagation delay in the sense, if the distance is high, then the propagation delay will be high. Okay, so this is what the thing. This is what delay factor related to transmission. Delay factor related to packet switching technique. Okay. Okay, let's simply calculate a delay with an example. Let us consider I have two nodes. Okay. Let me consider I have a host A. Host A is connected with host B. Host A is connected with the host B. And the distance between these, okay, so let us assume this channel is a fiber channel. Okay, so the distance is a little bit 2500 kilometer. Okay, 2500 kilometer, and this is again a fiber channel. If it is fiber channel, the capacity of this channel, 2.5 into 10 power 8 meter per second. Okay, and this host A is injecting the packet. The size of the packet is 1000 byte packet. Okay, and this channel R capacity of the channel. Okay, let it be. This is D distance, and this is V velocity, and this is L length of the packet, and the channel capacity and channel bandwidth. Okay, assume the channel bandwidth is 2 megabits per second channel. 2 megabits per second channel. Okay, so with this scenario, let us calculate the delay. Okay, the transmission delay and the processing delay. Okay, so the transmission delay is something like the time taken by the packet, taken by the host to inject the packet onto the link. Transmission delay. Okay, transmission delay is based on length of the packet and the capacity of the channel, that is L by R. What is the length of the packet? Length of the packet is 1000 bytes, not bit. Okay, but all the metrics are based on bits per second and bits. The delay is in terms of seconds. Okay, so let me convert this one into bits. So 1000 byte is equal to 1000 into 8 bits. Okay, by what is the capacity of the channel? The channel is 2 megabits per second. That is 2 into 10 power 6. Okay, so this is equal to 4 into 10 power minus 3. This is equal to 4 millisecond. Okay, so see, transmission time is very minimal, very negligible, very small negligible value, 4 millisecond. Okay, because the channel capacity is in terms of megahertz. Okay, let's get into the another delay. Okay, because the time taken by the host to inject the packet is 4 millisecond, but anyhow the packet travel from this end to this end. Okay, the traveling time is required. So the traveling time is based on the propagation delay. Propagation delay, let's consider the propagation delay for this. The propagation delay is based on the metrics called distance by velocity. So here the distance is 2500 kilometer, 2500 into 10 power 3. That is 2500 kilometer by the velocity fiber channel. The velocity is 2.5 into 10 power 8 meter per second. Okay, so this is equal to 0.015. Okay, so this is nothing but sorry, 0.01, not 5, sorry, 0.010. So this is nothing but 10 millisecond delay. Okay, so this is in terms of second and this is in terms of millisecond. Okay, so this is 10 millisecond delay. With the propagation with the capacity, it is with the velocity 2.5 meter, 2.5 into 10 power 8 meter per second velocity. Okay, so for example at time t0 it started injecting the packet. Okay, so it will reach the destination at time t0 plus tau. What is the tau? The tau is nothing but the transmission time plus the propagation time. Okay, so this is nothing but 15 millisecond. If the user started transmitting the data at 50 millisecond, then it reached the receiver in 20th millisecond. Okay, so but observe these two delays. These two delays are playing an important role in networking scenario. The transmission delay and the propagation delay. Let's talk about one by one. Now see this distance. Based on this distance, you can identify the type of the network. Okay, so we have personal area network and common local area network and wide area network. Okay, the 2500 kilometer, if the distance between the node is 2500 kilometer, definitely the underlying network is wide area network, not local area network. Okay, if you take local area network, the distance in terms of meters, okay, not in terms of kilometers. So that local area network or wide area network, two common type of network, local area network or wide area network. In the local area network, the distance is very high. Distance is high. Distance will be high, so that the propagation delay will be high and the transmission delay will be less. Okay, if you take local area network, the distance between the nodes are very less. Okay, it is very less. Okay, so that here for a wide area network, the propagation delay be high. Okay, it's very high. And if you take a local area network, the propagation delay will be low. Okay, because propagation delay will be low because the distance is in terms of meter. Okay, 2 meter or 2.5 meters or 3 meters. So if the distance is very low, automatically the delay, the propagation delay in the packet reached the destination with a small propagation delay, but the transmission delay entirely based on capacity of the channel. Now we have compared two different type of network, wide area network and local area network. Let's local area network and personal area network. If you talk about personal area network or a small scale network, the connectivity is in terms of radio communication, Bluetooth or Zigbee. Okay, so if you take a Bluetooth or Zigbee, the transmission rate, a channel capacity is in terms of kbps. Okay, if the channel capacity is in terms of kbps, even though if you take personal area network, even though the devices are closely located, okay, because it covers a meter distance. Okay, you may have the computer may be connected with a fax machine, connected with a printer in the Wi-Fi mode, or otherwise if you take body area network, plantable devices connected with a personal digital assistant. So distance is in less than meters distance. The propagation delay, if you take a personal network, the propagation delay will be low, very low. Propagation delay, it will be low, okay, because the distance is very minimal, okay. But the transmission time, if you take personal network, the mode of transmission is wireless, okay, and the common protocol is Zigbee or Bluetooth. The capacity is in terms of kbps. The transmission rate is in terms of kbps. So the transmission delay is based on the capacity of the channel. Okay, so the transmission delay is somewhat high because the capacity of the channel is very minimum. Okay, so the propagation delay or transmission delay depends upon the type of the network. Okay, so if the nodes are closely located, okay, as a conclusion, just get a simple point. If the nodes are closely located or closely connected with a short limited distance, then the propagation delay will be minimum. Okay, if the nodes are connected by using high capacity channel, fiber channel, okay, or high capacity channel, the transmission delay will be low. Okay, so if you take a wireless channel, or if you take fiber channel, or if you take compare fiber channel with the coaxial cable or fiber channel with the twisted wire, the capacity of the twisted wire is very minimum. Okay, so the transmission time with the fiber channel is somewhat less as compared to the transmission time with the twisted wire channel. Okay, so the transmission time is heavily based on the channel capacity. The propagation delay heavily based on the distance between the node. Okay, so whenever we talk about network metric, delay playing an important role. Delay is based on two performance metric, two infrastructure metrics. One is a channel bandwidth. Another one is the distance in which the nodes are connected together. Okay. Okay. So let's get into the next property or metric of network, packet loss. Okay, so packet loss, it depends upon the traffic intensity. Okay, so we have seen in the third lecture under the topic of switching, the packet loss is based on the amount of traffic injected by the network. Let's see a simple example here. I have a channel. The capacity of the channel is 1 megabits per second capacity, and this is attached with the switch. Okay, and the switch is connected with 4 nodes. Okay, and this is connected with the one host, and this is connected with another host, and this is connected with third host, and so on. Okay, let's see if all these channels are generating the data at the rate of 250 kbps. Okay, altogether only the 4 nodes are available. Amount of traffic generated by all the nodes never exceed 1 megabits per second, so that it won't drop the data, so there is no loss. Okay, let's assume each node generating the data at somewhat much higher rate, 500 kbps data. 500 kbps data generated by all the nodes at time t0. So altogether the amount of data generated is 500 kbps, and we have 4 nodes. Okay, so it will generate 2 megabits of data. Okay, if it generates 2 megabits of data, it will inject only 1 megabits of data. The remaining 1 megabits of data will be dropped. Okay, this is known as packet loss. Okay, so if there is no space in the buffer packet to store the packet in the buffer, router simply discard the packet. Okay, now, what do you mean no space in the buffer? Once the channel is busy, okay, then the packet will be stored inside the buffer. It will be retained in the buffer. Okay, once the buffer is full, automatically the packet will be dropped. Okay, that is known as loss. Loss will happen if the traffic intensity exceeds the availability. Okay, and next further metric is known as throughput. Okay, so throughput we can classify into two type. One is instantaneous throughput, Another one is average throughput. Okay, at particular instant of time, what is the rate at which the host B receives the file? Okay, so for example, it receives the file at the rate of 1 megabytes per second, then that is a throughput. Okay, so throughput is in terms of bits per second. Let's consider we need to transmit f bits. Okay, some 64,000 bits to be transmitted, and the time taken by the system or network to transmit that file is t second. Okay, now host B will receive all the f bits in t second period of time. Then what is the throughput? Throughput is nothing but f by t. Okay, that is actually average throughput. So most of the time average throughput matters. How will you find out average throughput? The average throughput is based on two metric. What is that? Length of the data divided by time required to transmit the data to the destination. Okay, so this is actually transmission time and this is length of the data. Okay, so throughput is also an important metric to analyze the network structure. For better network, we need higher throughput. Okay, so in order to get the higher throughput, definitely the time required to transmit the data should be a minimum. Okay, so if you want to get a minimum transmission time, then the propagation, the capacity of the channel should be high. Okay, so again, throughput is based on channel capacity again. That is bandwidth of the channel. That is how much amount of data that can be injected onto the channel. Okay, but normally in the real sense, two nodes, source and destination. Let it be this is source and this is destination. Source and destinations are not directly connected, not peer-to-peer connection, not having peer-to-peer connection. Okay, it will be connected through entire sub network. Okay, so here it is connected through one router, but here we have n routers. The first router and second router. This is n minus one router. Okay, so if it is so, we cannot find out, it's not possible, and moreover these links are also heterogeneous link. Okay, assume in this case this is 1 megabits per second link. Okay, and this is 2 megabits per second link. Okay, if it is so, the server can inject the data based on the capacity of the link. What is the capacity of the link here? 1 megabits per second. Okay, so here itself the pipe is narrowed. Okay, so once it comes here, this side can inject 1 megabits of data, even though the capacity of this link is high, larger than this. Cannot possible to transmit the data at the rate of 2 megabits because the first link is just 2 megabits per second link, sorry 1 megabits per second link. Okay, so it is not possible to transmit the data beyond this 1 megabits. Okay, so the receiver will receive the data at the rate of only 2 megabits per second. So here the throughput is based, sorry 1 megabits per second, here the throughput is based on 1 megabits. Okay, so now what is the thing here? The throughput heavily based on the narrowed link, smallest bandwidth, limited bandwidth link or bottleneck link. I can call it as bottleneck link. Okay, so in this case, the bottleneck link is R1 because RS server connected with a router with a narrowed pipe. Okay, so that link affects the entire throughput. Entire throughput is based on the minimal link, or otherwise I can generalize it like this. See, here I have a number of channel, a number of routers, n minus one routers, and server is a source and the destination is the client. Okay, the packet should travel from source to destination through this router. Okay, now here n minus one n links are there. Server is connected with this router, first link. The router 1 is connected with router 2, second link, and so on, and n minus 1th router connected with the destination. Totally it passes through n links. Okay, so here the average throughput is based on, I can write it like this, average throughput is nothing but minimum capacity of these links. Okay, it's not possible to inject the data beyond the capacity of the bottleneck link. Okay, so minimum of the capacity of link R1, capacity of link R2, capacity of link Rn. Okay, so now here this may be all the links may be 1 megabytes per second, 1 megabytes per second link. Any one of the link is 1 kbps link, and throughput will be 1 kbps only. Okay, so the throughput is based on the capacity of the channel alone. Okay, packet loss is based on the traffic intensity, but throughput is based on the capacity of the channel. Like if the capacity, number of links and the capacity of the link. Okay, so if there is more than one link, then bottleneck link playing an important role to find out the throughput. Throughput is based on the bottleneck link. What is throughput? Throughput is nothing but the amount of data received by the receiver per unit of time. Average throughput is L by R. Okay. So these are the three important metrics which are widely used to validate the performance of any type of network. Okay. So delay. Let's see it again. Thing here. So delay and loss and throughput. These are the three important performance metrics to compute or validate the performance of any type of network. Okay, so in delay in specific, the major role played by transmission delay and propagation delay. So in delay, nodal processing delay, both are it's very minimal or negligible. Okay, so but the packet loss is based on the traffic intensity or how many nodes are connected with the networks. Okay, if number of nodes are connected with the network is high, then all the nodes may contribute in the traffic. If all the nodes are transmitting the data at the same time, if it exceeds the bandwidth, then automatically packet loss will occur. Okay, the throughput depends upon the number of links as well as the bottleneck link. In specific, bottleneck link. Okay, if any one of the link is having a very a small capacity or bandwidth, definitely the throughput will be very low. Okay, but the transmission time depends upon the capacity of the single channel, but throughput depends upon the capacity of the channel which are connected in the path. Okay, the packet travel from source to destination. For throughput computation, we have to consider all the links which are connected between the source and destination. Okay, if any one of the link is having less bandwidth, definitely the throughput will be less because it is not possible to pump the data beyond the capacity of the bottleneck link. Okay, so these are the metrics which are evaluating, which are used widely used to evaluate the performance of the net.